Dear 11th standard students, in previous video class, you have knowledge about or knowledge gained from some topics. For example, potential energy possessed by a body, kinetic energy possessed by a body. So potential energy and kinetic energy, these energies belongs to mechanical energy. What is potential energy? Potential energy possessed by a body due to gravitational force. And also, potential energy possessed by a body due to its virtue of its position. Next, kinetic energy. Kinetic energy possessed by a body due to its motion. All moving bodies possess a kinetic energy. See, mechanical energy. Before going to see about the topic law of conservation of energy, first we know about the concept of mechanical energy. Mechanical energy is classified into two types. One is potential energy. Another one is kinetic energy. Potential energy, here one kind of potential energy is a gravitational potential energy. Gravitational potential energy is gained by a body due to gravitational force. So it can be calculated from this equation mgh. So where m is the mass of an object, g is the acceleration due to gravity, h is the height of an object from the ground. Then kinetic energy is possessed by a body due to its motion of the body. It can be calculated by this equation of mv square. M is the mass of an object, v is the velocity of an object. So, potential energy and the kinetic energy belongs to that of mechanical energy. So, in the case of potential energy, potential energy is gained by a body due to gravitational force. A gravitational force is one of the conservative force. It is a ground. For example, let me take an object of mass m initially placed at the surface of the earth. Now, I am giving some initial velocity to that object thrown vertically upward direction. During its motion, velocity of an object decreases with constant rate. Velocity decreases. So at the time of body is thrown vertically upward direction, that body possesses a maximum kinetic energy. So during its motion of the body upward direction, velocity of your body decreases with constant rate. If the body reaches a maximum height, h is maximum, at the maximum height, velocity of your body is 0. So, see that activity. At the time of body is thrown vertically upward direction, velocity of your body is maximum. If it is velocity of your body is maximum, that body possesses a maximum kinetic energy. Kinetic energy is maximum of mv square, that is kinetic energy, which is equal to maximum. So at that instant of time, if your body is thrown vertically upward direction at that instant of time, height of your body from the ground H is equal to 0. So therefore, hence, potential energy which is equal to mgh, which is equal to 0 because height which is equal to 0. So at the time of body is thrown vertically upward direction, at that instant of time, kinetic energy of your body is maximum, at that simultaneously potential energy of the body is 0. Here, the body is acted upon by a conservative force like a gravitational force. Total energy of the system of an object remains to be constant. At that instant, total energy E, that is total energy, which is equal to sum of its potential energy and kinetic energy. Potential energy is denoted by the symbol U and the kinetic energy is denoted by Ke. So the total energy is denoted by the symbol E. So at the time of body is thrown vertically upward direction, total energy E, which is equal to potential energy is 0, but it possesses a maximum kinetic energy. Then during its motion, velocity of your body is decreases with the constant rate. Then what happens? Kinetic energy. Kinetic energy Ke, which is equal to half mv square. If mass of an object will not change, but velocity of your body is decreases with the constant rate, kinetic energy of your body is goes on decreases. So kinetic energy decreases, then what happens? Potential energy. So potential energy of your body is entirely depends upon height. If height of your body increases, then potential energy of your body keeps on increasing. So keep it in your mind. If your body is thrown vertically upward direction from on its ground, kinetic energy goes on decreases, but the potential energy keeps on increases. If your body is reaches at a maximum height, so what happens? Potential energy. So if your body is reaches a maximum height, potential energy is mgh, which is maximum. Then what happens? Kinetic energy. At the maximum height, velocity of your body is 0. Then kinetic energy of your body of mv square. Mass of an object will not change. But if your body reaches a maximum height, velocity of your body is 0. Then of m, v value is 0, kinetic energy is 0. At the maximum height, total energy of your body E, which is equal to sum of its potential energy and kinetic energy. So at the maximum height, potential energy is maximum mgh, but the kinetic energy is 0. At the maximum height, total energy is mgh, that is wholly potential. So here I am talking about if your body is thrown vertically upward direction, initially I am imparting energy to that body. That energy is in the form of kinetic energy. I am giving some initial velocity while throwing the body vertically upward direction. That body gains some energy. That energy is called kinetic energy. If your body goes upward direction, vertically upward direction, velocity of your body decreases with the constant rate. Kinetic energy of your body goes on decreases, but the height of your body increases, then potential energy keeps on increasing. If your body reaches a maximum height, potential energy of your body is maximum. At the maximum height, velocity of your body is 0, hence kinetic energy of your body is 0. At the maximum height, the total energy of your body is wholly potential. If your body is thrown at that instant of time from on the surface of the ground, total energy of the body is wholly kinetic. In upward direction, how we calculate velocity of your body at any instant of time? It is possible to calculate velocity of your body at any instant of time. In the case of body is thrown vertically upward direction or freely falling body. You know about three types of equation of motion. V is equal to U plus GT, S is equal to UT plus half GT square, V square is equal to U square plus 2G S. This is a three equation of motion. From these three equation of motion, we can calculate the velocity of your body at any instant of time during its motion in R. S is the distance travelled by an object, which is equal to ut plus half gt square. V square is equal to u square plus 2gs. This three equation is very helpful to us to calculate velocity at any instant of time, distance covered by an object at any instant of time if the body is thrown vertically upward direction or freely falling bodies. It is V is also velocity of your body at any instant of time if you knowing the distance covered by a body at that instant of time. Yes. So V square is equal to U square plus 2GH. Depending upon body is thrown vertically upward direction or freely falling body, the G is taken as either positive or negative. If your body is thrown vertically upward direction, vertically thrown up, how these three equations can be modified? V is equal to U minus GT. The G value is taken as minus G. S is equal to UT minus half GT square. V square is equal to U square minus 2GS. Then, if you are freely falling body, how these three equations can be modified? Freely falling bodies. So, here freely falling bodies, the G value is taken as positive. V is equal to U plus GT. S is equal to UT plus half GT square. V square is equal to U square plus 2GS. These kind of equations will helpful to us to explain the law of conservation of energy. In this equation, S replaces by H, and also in that freely falling bodies, initial velocity of an object is 0, u. For the case of freely falling bodies, initial velocity of an object is 0. Keep it in our mind. Now, already you know about potential energy and the kinetic energy. Potential energy possessed by a body due to gravitational force can be calculated from this equation mgh. Here m is the mass of an object, g is the acceleration due to gravity, h is the height of an object. Here mg is constant at a given place, but height is variable. If a body is thrown vertically upward direction from the surface of the ground, height of the body increases. Simultaneously, potential energy possessed by a body also increases. Then, kinetic energy of mv square. Where m is the mass of an object, v is the velocity of an object. If a body is thrown vertically upward direction, at that instant of throwing time, velocity is maximum. But if a body goes upward direction, velocity decreases with the constant rate. Hence, kinetic energy also decreases. So, this kind of potential energy and the kinetic energy belongs to mechanical energy. But if a body is thrown vertically upward direction or freely falling bodies, it possesses two kind of energies, potential energy and kinetic energy, depending upon the position and the motion of an object. So, gravitational force is a conservative force. If I am giving some energy to that object, that the total energy of the isolated system will not change. It remains to be constant. So now we are going to see about important topic, how we see the law of conservation of energy. So what is conservation? Conservation means constant. In the gravitational force is one of the conservative force, total energy of the isolated system remains constant or will not change. So initial total energy and the final total energy remains to be constant, it will not change. Dear students, now we see the topic of law of conservation of energy and the previous concept of potential energy and kinetic energy. These energies are belongs to mechanical energy. See, it is the surface of the ground. Take one object of mass m, initially placed at the surface of the earth. Now I am taking the mass of an object m, impart some energy to that object thrown vertically upward direction. It possesses a velocity. At that instant of throwing vertically upward direction, it possesses a velocity v. It possesses a maximum velocity. At that instant of time, height of an object is 0. Height of an object is measured from the surface of the ground. Initially, that object is placed at the surface of the ground. Height of an object is 0. But I am throwing the object, giving some energy to that object. It possesses a kinetic energy because that velocity acquired by the body is maximum. That velocity imparted from the external source to that object. It possesses a maximum kinetic energy at that instant of throwing time. At that instant, kinetic energy initially at the throwing time potential energy P, which is equal to mgh. Here height of an object is 0, potential energy mg 0, then potential energy is 0. So what happens kinetic energy at that instant of throwing time from the surface of the ground? Kinetic energy, which is equal to half mv square. So mass of an object is there, then velocity of an object at that throwing time is maximum, then kinetic energy is maximum. So what happens? Total energy possessed by a body at that instant of throwing time vertically upward direction. Total energy E, which is equal to sum of its potential energy like U and kinetic energy of mv square. So at that instant of throwing time initially, total energy E, which is equal to potential energy U and kinetic energy Ke. Then total energy E, which is equal to potential energy is 0 and kinetic energy is maximum. The total energy, which is equal to kinetic energy. At that instant of throwing time, if a body is thrown vertically upward direction, total energy of the body is wholly kinetic. This is first case. Next, the body is moving upward direction. At that intermediate position, at any one position in air, here air resistance is negligible, that is important. If a body is thrown upward direction at that instant of throwing time, the body possesses a maximum total energy. That maximum total energy is wholly kinetic. If moves upward direction, velocity of your body goes on decreases, hence kinetic energy decreases. Decreasing kinetic energy reappears in the form of potential energy because height of your body from the surface of the ground increases. Now height increases. If your body covers a y distance from the surface of the ground, at that instant that body possesses here two kind of energies, both potential energy and also kinetic energy. Depending upon the height covered by a body, it possesses a potential energy, and velocity, it possesses a particular velocity, but velocity decreases, kinetic energy decreases. Anyhow, at that instant it possesses a certain velocity, at that instant of time it possesses a kinetic energy. So at that intermediate position, intermediate point or position, the body possesses a potential energy, mgh. Here h is equal to y. So therefore potential energy P is equal to mgy. And kinetic energy possessed by a body K is equal to half mv square. At that instant it possesses a velocity, but velocity is lesser value, hence kinetic energy half mv square. Then what happens? The total energy at that intermediate position E is equal to potential energy plus kinetic energy E, which is equal to potential energy U plus kinetic energy Ke. So at the intermediate point, potential energy increases, kinetic energy decreases. The decreasing kinetic energy reappears in the form of potential energy. Anyhow, at this intermediate point, total energy of the isolated system of an object remains to be constant. That energy is now in the format of two energy, potential energy and kinetic energy at the intermediate. So dear students, now that object is crosses from the intermediate point, goes to vertically upward direction to reach as the highest point. It covers a distance or it covers a height h. This is highest point. At the highest point, velocity of an object is 0. So at the highest point, kinetic energy of an object Ke, which is equal to half mv square. At the highest point, velocity of an object is 0. If any body is thrown vertically upward direction reaches a maximum height, velocity of an object is 0 at that instant of time. V is equal to 0. Then kinetic energy possessed by a body of m, V value 0, kinetic energy which is equal to 0. Then at that instant of time, what happens? Potential energy gained by the body. Potential energy P is equal to mgh. At that instant of time, height of a body is maximum, then it possesses a potential energy mgh, that is maximum. So at the highest point, or if a body covers a highest height, then what happens? The total energy possessed by a body E, which is equal to sum of its potential energy and the kinetic energy. E, which is equal to potential energy mgh and the kinetic energy is 0. At the maximum height, total energy possessed by a body is mgh. So at the highest point, total energy possessed by a body is wholly potential. At the highest point, the total energy possessed by a body is wholly potential. Now, with the same energy is possessed by a body at that instant of time, is body is thrown vertically upward direction, the total energy of the system of an object will not change. It is law of conservation of energy. So, dear students, keep it in your mind. If your body is thrown vertically upward direction at that instant of time from the surface of the ground, total energy possessed by a body is wholly kinetic energy. See, keep it in your mind. Then bodies goes vertically upward direction. Height of your body increases, velocity of your body decreases. Kinetic energy of your body decreases due to decreasing velocity. Then potential energy of the body increases with the increasing height of the body at that intermediate position. See, is the intermediate position. The total energy possessed by a body is a sum of its potential and kinetic in that intermediate position. Anyhow, at the intermediate position, total energy remains to be constant, will not change. It is as the same that of if a body is thrown vertically upward direction at that instant of time from the surface of the ground. So okay, if your body reaches a maximum height, velocity of your body is 0, hence kinetic energy is 0. If your body covers a maximum height, potential energy possessed by your body is maximum mgh. So at the highest point, the total energy possessed by your body is only potential energy. So total energy is wholly potential. So at the highest point also, the total energy of the isolated system remains to be constant, is the same that of intermediate position. At the same that of if a body is thrown vertically upward direction at that instant of time from the surface of the ground. According to law of conservation of energy, energy neither be created nor be destroyed, but one kind of energy is transformed to the other kind of energies. Anyhow, total energy of the isolated system of an object remains to be constant. Here see, at the time of throwing, if a body is thrown vertically upward direction, total energy is wholly kinetic. If a body reaches the intermediate position, total energy is sum of its potential and kinetic. Because during its motion in that upward direction, velocity decreases, kinetic energy decreases. The decreasing in kinetic energy reappears in the another format. That another form of energy is potential energy. How much amount of kinetic energy decreases, the same amount of energy reappears in the form of potential. But anyhow, total energy and that intermediate position remains to be constant as the same. Then if a body reaches a maximum height, kinetic energy is 0 because velocity is 0. So that entire kinetic energy disappears. The same amount of energy reappears in the form of potential energy. At the highest point, the total energy of the isolated system is wholly potential. It can be explained on the basis of freely falling bodies also. So this is the law of conservation of energy. Energy neither be created nor be destroyed, but one form of energy is transferred to the other form of energy. So here, at the time of throwing the body vertically upward direction, total energy is kinetic. If your body reaches a highest position, the total energy of the body is wholly potential. So potential energy and the kinetic energy both is equal, then the total energy of the isolated system remains to be constant. So dear students, now we see one problem on the basis of law of conservation of energy. You know of law of conservation of energy. Energy neither be created nor be destroyed, but one kind of energy is transferred to the other kind of energy with equal amount. See the problem. An object of mass 1 kg, mass of an object is 1 kg, is falling from the height h is equal to 10 meter, height of an object is 10 meter. Calculate the total energy of an object at a height h is equal to 10 meter. First we are going to see the A. What is the total energy of an object at a height 10 meter? See the diagram. It is the ground. Okay. See the height of an object from the surface of the ground, h is equal to 10 meter. Mass of an object which is equal to 1 kg. At the height, velocity of an object is, initial velocity of an object is 0. Then at that instant, the kinetic energy of the object is 0. Then height of an object is 10 meter. Depending upon the height, that object is possess a potential energy. The total energy of the object is wholly potential if an object is placed at a height 10 meter from the surface of the ground. The total energy E, which is equal to potential energy and kinetic energy. Here at the maximum height 10 meter, kinetic energy is 0 because at the maximum height velocity of an object is 0. So total energy at the maximum height E is equal to potential energy mgh. So the total energy which is equal to mass of an object 1 kg, acceleration due to gravity taken as 10 meter per second square. Then height of an object from the surface of the ground is 10 meter. Then total energy which is equal to 100 joule. So we completed first question. Total energy of an object at a height h is equal to 10 meter. The total energy is Holy potential. Next, second B. Potential energy of the object when it is h is equal to 4 meter. Now the second, if your body is allowed to free fall, then it will move towards the surface of the earth. It covers a height at that instant. Height of an object from the surface of the ground during its falling, h is equal to 4 meter. So, height is equal to 4 meter. At that instant, what is the potential energy of the object when is at h is equal to 4 meter? So, potential energy P which is equal to mgh. Potential energy P is equal to mass of an object 1 kg, g value 10, height of an object from the surface of the ground 4 meter 4. Then potential energy of an object is 40 joule. Next, go to the other question C. Kinetic energy of an object when it is an h is equal to 4 meter. If a body at the height 4 meter from the surface of the ground during its freely falling, at that instant it possesses a particular velocity, and also it is a position of an object from the surface of the ground 4 meter. That's why it possesses both the potential energy. So at that instant of time from the surface of the ground 4 meter, the total energy possessed by a body is a sum of its potential and the kinetic. So therefore, C, so total energy E which is equal to sum of its potential and kinetic. Now aim to determine at the height 4 meter, what is the kinetic energy of the object? Kinetic energy of an object Ke which is equal to total energy minus potential energy. Kinetic energy of an object Ke which is equal to total energy, already we found 100 joule, and the potential energy at the height 4 meter 40 joule. Then kinetic energy Ke which is equal to 60 joule. See, at a height 4 meter, at a 4 meter height, potential energy is 40 joule and the kinetic energy is 60 joule, but the total energy possessed by a body at the maximum height is 100 joule. The total energy will not change, but at the intermediate position, the total energy is a sum of its potential and the kinetic, but the total energy of the isolated system remains to be constant like 100 joule. Next, in our aim to calculate what will be the speed of an object when hits the ground. So D, speed of an object if an object touches the ground. Dear students, in that freely falling object, if an object is a particular height from the surface of the ground, initial speed of an object is 0. If that object is allowed to fall freely, velocity of the body or speed of the body keeps on increases with a constant rate. If that body is before touches the ground at that instant, velocity of your body is maximum. In our aim to calculate what is the speed of an object if that object touches with the ground. It can be calculated from this equation of motion v square which is equal to u square plus 2gh. So in that freely falling body, body's initial velocity of an object is 0, then v square is equal to 0 plus 2gh, then v square is equal to 2gh V is equal to square root of 2gh. So speed of an object, if an object is touches with the ground, V is equal to square root of 2, g value 10. That freely falling body touches the ground, it covers a height 10 meter. So V is equal to square root of 100 into 2. V is equal to 10 into root 2. V is equal to 10 into 1.414. V is equal to 14.14 meter per second. So this is the speed of an object touches with the ground. It possesses a maximum speed if that object is touches with the ground. So we found all 4 problems in this main problem. We prove law of conservation of energy. So law of conservation of energy is very simple. In the universe, total energy of the isolated system of an object remains to be constant. That energy will not waste at any form. One form of energy is reappears in that another form of energy with equal amount. This is very important in that law of conservation of energy. Thank you, students.